This training is designed to prepare remote pilots for the Sectional Charts and Airspace portion of the FAA Part 107 Knowledge Test, often the most challenging section for new applicants. The first topic to be introduced will be sectional charts. A sectional chart, or sectional aeronautical chart, is the primary, 1 to 500,000 scale map used by pilots for visual flight rules navigation in slow to medium speed aircraft. The information found on a sectional chart includes topographical data, aeronautical information, navigational landmarks, safety data, and scales. Sectional charts at first can look very busy and unreadable, but in using them, the information becomes easier to interpret and use. Some of the information you must know on sectional charts include latitude and longitude lines, airports, air traffic control tower info, airspace classification, airspace floor and ceiling information, obstacles, travel routes, as well as other information that will be introduced in this video. In order to effectively read a map, a pilot must be able to read latitude and longitudinal information on a map. Latitude and longitude form an imaginary geographical grid system used to pinpoint any location on Earth using coordinates. These help determine exact coordinates for low-altitude authorization and notification capability authorizations, flight planning, and emergency location reporting. Latitude lines run east to west and measure north to south. The measurements start at the equator, which is the 0-degree mark, and count upwards to the north and downwards to the south. Longitude lines run north to south and measure east to west. The measurements start at the prime meridian, which is the 0-degree mark. They then count upwards to the west at 1 degree and wrapping back to the prime meridian. Sectional chart coordinates are read in degrees, minutes, and seconds. Each degree is divided into 60 minutes, with 30-minute intervals explicitly marked. Larger tick marks occur every 5 and 10 minutes. Similarly, each minute is divided into 60 seconds. An example of how this would read is 36 degrees, 9 minutes, 30 seconds north. 75 degrees, 44 minutes, 20 seconds west. Isogenic lines are lines on a map connecting points on the Earth's surface with equal magnetic variation. It is the difference between true north and magnetic north. If the variation shows 10 degrees west, then magnetic north is 10 degrees west of true north. Here you can see the latitude and longitude lines and information on a sectional chart. The degrees coordinates are located on at least one line of latitude and longitude on the chart. With the chart removed, here, you can see the vertical lines of latitude and the horizontal lines of longitude. The distance between each line of latitude is 30 minutes. And every 2 lines represent 60 minutes, which equates to 1 degree of latitude. Similarly, the distance between each line of longitude is 30 minutes. And every 2 lines represent 60 minutes, which equates to 1 degree of longitude. Understanding the distance transition of lines of latitude will help read and find coordinates faster. Here you can see that as you move north from 48 degrees, the next line is 48 degrees, 30 minutes, and then 49 degrees. And here as you move left or west, 101 degrees moves to 101 degrees, 30 minutes, followed by 102 degrees. Between each main line of latitude or longitude, there are incremental minute markers. The small ticks represent 1 minute. The slightly larger ticks represent 5 minutes. And the largest ticks are 10 minutes. By reading the larger ticks, you will be able to find the specific minutes associated with map coordinates. Again, the ticks represent 5 and 10 minutes, so for a latitude movement from 48 degrees to 49 degrees, the ticks measure 5, 10, 15, 20, 25 minutes, then 30 minutes as it reaches the next main line, and continuing to 35, 40, 45, 50, and 55 minutes, before reaching the 49-degree line. Counting longitudinal lines works in the same fashion. Starting at 101 degrees, counting to the west, the ticks are for 5, 10, 15, 20, and 25 minutes before reaching 101 degree, 30 minutes. From there are ticks for 35, 40, 45, 50, and 55 minutes before arriving at 102 degrees. Now for an example. A question may read what airport is located at 47 degrees, 39 minutes north, 101 degrees, 26 minutes west? To figure this out, first find the main latitude and longitude lines on the map. Next, move along the latitude lines, counting down the major ticks. The first is the 50 minutes tick, and the second is 40 minutes. Then count across to the ticks for 10, 20, and 25 degree lines. Then find where these 2 points meet, and you can see it is Garrison. So the answer would be B. The next area is airspace classifications, which is critical knowledge for drone pilots. The first thing that must be understood related to airspace is AGL and MSL. AGL stands for above ground level, and it measures altitude directly above the terrain, while MSL or mean sea level measures height relative to the average sea level. AGL is crucial for obstacle clearance and drone operations, whereas MSL is standard for aviation navigation, airspace, and weather reports. For context, if you are on top of a 2,000-foot mountain, your AGL is 0 feet, but your MSL is 2,000 feet. A class of airspace is either controlled or uncontrolled. Controlled airspace is where air traffic control has the authority to control traffic. In uncontrolled airspace, they don't. The classes are A, B, C, D, E, and G. Class A covers 18,000 feet MSL up to FL 600 Oregon 60000 feet MSL. This airspace is controlled, which requires instrument rating and transponder. Class B includes the surface to 10,000 feet MSL and requires air traffic control clearance to enter. Class C is from the surface to 4,000 feet AGL and two-way radio transponder required. Class D covers the surface to 2,500 feet AGL. These are found around smaller airports with towers and a two-way radio required. Class E is for everywhere else, typically starting at 700 or 1,200 feet AGL, up to Class A airspace at 18,000 feet MSL. And Class G is uncontrolled airspace from the surface up to Class A, B, C, D, or E controlled airspace. Class B airspace is identified with solid blue lines on the map. It surrounds major airports like New York's JFK, Atlanta's ATL, and Los Angeles LAX. The shape is like an upside-down wedding cake. And Class B airspace always require authorization for Suez flights. Class C airspace is identified with solid magenta lines. It is used around medium-sized airports. And it also requires authorization to fly within these areas. Class D is identified by dashed blue lines. They are typically found around small tower airports. And they require authorization to enter. A bracketed number is found in Class D space, which represents the ceiling in hundreds of feet. A minus ceiling value indicates the surface up to but not including that value. Class E have multiple styles to identify them on maps. Dashed magenta displays Class E airspace starting at surface, while magenta shading begins at 700 feet, and blue shading shows Class E beginning at 1,200 feet. There is no authorization required for E unless operating controlled airspace near airports. Class G is uncontrolled airspace, with no visible markings on a map. It falls from surface to the start of overheard airspace, which could be any from A to E. No authorization is required to fly in Class G airspace. In addition to airspace classifications, there are several categories of special use airspaces that must be understood. First is restricted airspace. These are identified by a blue hash border and have an R with a 4-digit number. They are hazardous activity areas such as those used for artillery or aerial gunnery. Restricted airspace may be active or inactive. A drone pilot must check the status before flying into these airspaces. Prohibited areas are do not enter areas under any circumstances. An example would be the White House. These are identified by a blue hashed border and have an P with a 3-digit number. MOAs, or military operations areas, are locations where intense military training is conducted. These have a specific name title followed by MOA, for example Fallow South 2 MOA, with a magenta border marking off the specific space. You can fly a drone but expect and be aware of the presence of high-speed air traffic. Military training routes, or MTRs, appear on sectional charts as thin, solid gray lines with names like VR1053 or IR206, often accompanied by arrows indicating direction. They are used for high-speed tactical training. VR routes, for visual rules, are generally used below 1,500 feet AGL and have a 4-digit number, while IR, for instrument rules, can be higher and have a 3-digit number. They are routes used by the military aircraft to practice maneuvers at high speeds and low altitudes. Warning areas extend from 3 nautical miles outward from the U.S. coast, often over both domestic and international waters. They warn pilots of hazardous military, testing, or training activities. These are identified by a blue hash border and have the word warning and a W with a 3-digit number. National parks prohibit drone operations by federal rules. This is primarily to protect wildlife, ensure visitor safety, and maintain the tranquility of natural landscapes. They are not charted as special use airspace, but must because they are no-fly airspaces they must be recognized here. It is important to understand airport symbols and other information when doing pre-flight checks. Airports with control towers are identified in blue, and those without control towers are in magenta. The closed circle around the runways indicate runways that are between 1,500 and 8,069 feet in length. Those without circles are greater than 8,069 feet. The Common Traffic Advisory or CTAF and ATIS or weather frequencies will be listed. An L indicates lighting is available at the airport, and a star icon before the L indicates a rotating beacon. Obstacles that can affect flight operations are indicated on the map. An inverted V with a single dot displays a single obstacle in that area. If there are multiple inverted Vs with dots, then there are multiple obstacles in close proximity. There will be 2 numbers presented with obstacles. The top number is the height of the obstacle in MSL. The bottom number in parentheses is the height in AGL. You may be asked questions related to runways and entering fly patterns around into an airport. Runways are numbered, and the numbering system is determined by the direction it faces. They are labeled 1 to 36 based on the magnetic azimuth to the nearest 10 degrees they are running. A 27 means 270 degrees, and the opposite end of 9 means 90 degrees. If there are multiple parallel runways, they are designated a L for left, C for center, and R for right. For examples 18 liters, 18C, and 18R. For the exam, you will need to know that flights entering a pattern around the airport will always enter from a 45-degree angle. Another reference on the FAA's sectional aeronautical chart is a legend that explains every symbol on the map. They include things like airport symbols, both towered and untowered, airport data, air traffic service and airspace information, topographical information, miscellaneous information, radio aids to navigation, communication boxes, and obstruction information. The next few slides provide some additional information that must be understood as part of the Part 107 exam. The phonetic alphabet is used in the aviation industry. It is a 26-word system used to ensure clear, accurate communication over radio or telephone, particularly in noisy environments. It assigns a unique word to each letter to avoid confusion, such as Alpha for A and Zulu for Z. When communicating with control towers or other aircraft, it is important to use the phonetic alphabet. Also, aviation uses a military time 24-hour clock, starting at 0000 and ending at 2359 to avoid AM and PM confusion. Military time always uses 4 digits to report the time. Afternoon times add 12 to the current time, like 3 o'clock p.m. becomes 1500, while AM times remain similar, For example, 1 a.m. is 0100. If you plan to fly drones, it is important to learn these two systems as they are ingrained in the aeronautics industry. Another important thing to know about the aeronautics industry is that reported time is typically using the time from the Zulu time zone. The Zulu time, represented as Z, is the standard 24-hour time used in aviation, navigation, and the military, representing Coordinated Universal Time at the prime meridian, which is 0 degrees longitude. It remains constant worldwide, unaffected by local daylight saving time changes, and acts as a universal reference to ensure safety and accuracy in flight operations, scheduling, and weather forecasting. And understand cardinal directions in comparison from your location. For example, if you are flying at 90 degrees, and you receive a call of traffic at 3 o'clock at 4 miles, what direction would you look? East, west, or south? When flying at 90 degrees, 12 o'clock would be straight ahead on an easterly path. So, west would be 9 o'clock and south would be 3 o'clock from your position. Therefore, the answer would be C. Understanding sectional charts in airspace is important for safe drone operation and required knowledge for the Part 107 Knowledge Assessment. Thank you for watching this video. Please hit the subscribe button to access additional FSTG videos.